Hi, this is introduction or description of my latest project, GlooEye, which I've been working for 2 months almost. So the name is the mix between Glue and UI, and trying to change it until I find a free domain. So that's why it's GlooEye. And what is it? It's still not clear. A definition. There's more than one definition. But one of them that I like for technical people is a unified REPL for APIs, databases, and services. It should solve this problem. A technical person wants to interact with an API and wants to get some data out of it to solve a problem. Maybe once, or maybe if it's easy enough, automate it for later use. But the API is confusing, and you need to use a programming language, probably printing out the results into the console and seeing the output. And the API itself doesn't provide any interactive component to explore it, and the documentation is either missing or really bad. So that's one of the solutions that it may solve, the problems that it may solve. The other approach is there's been a wave of attempts at taking some parts of the logic of programming out of programming into configuration. Here is a bad offender. The usual case is that the pendulum goes from like Turing complete language into static configuration, and it swings back, and you get accidentally Turing complete configuration languages. This is a Helm chart, which is a configuration file in quotes in YAML to tell Kubernetes to do something. But of course, at some point you run into the limitations of the configuration language, so you add some templating on top, and then you need some conditionals and some loops, and you add that on top, and you get this pseudo Lisp with a template language that I think it's Go templating library, which it's like a lexical or string template library. It doesn't know anything about the AST of YAML, and the worst problem is that YAML is indentation sensitive. So if you introduce the wrong number of spaces in this template, then the result is not the one you want. So it makes it really worst. So trying to solve this problem, there have been a couple of projects. One of these is the DAL configuration language, maintainable configuration files, a programmable configuration language, JSON plus functions plus types plus imports, so it's typed. And the idea is to have a really simple, pure, I think, programming language, other than reading files for inclusion. That can be statically analyzed but provides some of the benefits of a programming language. Another one is Q, configure, unify, execute, validate, define, and use the dynamic and text-based data. It's pretty similar. It's not so type-heavy, Haskell-inspired, but it's in the same place. Nickel, a configuration language for NICs, also typed, has the same objectives. Write complex configuration, modular, correct, and boilerplate free. And from Google, I think it's from Google, JSONet, which is side effect free, generates configuration data, organize, simplify, unify, and it has variables, conditionals, arithmetic functions, imports, and error propagation, which it's pretty close to a programming language, but the output is a configuration file. So all of these are in this space from Thomas Petricek article. And so at the bottom, easy, small, we have use. You use a thing. On the top right, hard and large, we have programming. And in between, we have what we could call configuration, closer to use, and glue, a little bit higher, which is configuring, but also connecting different things, inputs and outputs. So this is the space the project GlooEye is trying to help solving. The idea is to create a live visual configuration or glue language. This is if we see programming as a spectrum, going from printing hello world on one side and formal proofs or verification on the other, or hardcore algorithms. The idea of GlooEye is to take out the leftmost side, which is configuration and glue, out of programming. I don't know if I want to be related to YAML, but we could call it visual YAML. The objectives are to remove glue out of programming and stretch small scripts. That the thing you would do with a small script that maybe you run on cron, you could do with this tool. And the usual thing that happens is that when we manage to create tools that take out a niche of programming out of programming, programmers will say, of course, because that's not programming, like HTML and CSS. My objective is to get people from Hacker News to tell me that, of course, it's easy because that's not programming, and I will be really happy. And I want to make those kinds of problems, that niche, go from high floor, high ceiling, which is what I think programming languages are right now, which they allow you to do anything, but it's really hard to start and use and learn, to middle to low floor, middle ceiling. Like the big objective is to be low floor, middle ceiling, but probably will land more into the middle floor, middle ceiling. It will take a little bit more effort to learn and to use than just using a tool, but it will allow you to solve problems that are in the long tail, which usual no-code tools are basically parametrical problem solvers. They pick a problem, they find like what's the 80% of the variation of the problem that most people care about, and then they parameterize the UI to solve those. And so it's like big block configuration. You some conditional, do this or do that, but not so compositional and like combinatorial as a programming language. So why I'm doing this this way? Because one of the main differentiators of GlooEye from other no-code tools is the way that the UI is created and presented and manipulated. And I'm trying to run away from the two kinds of problems that UIs run into when they are trying to provide a simple, easy to use UI to solve a complex and ever-growing variations of a problem. And the first one is, this is Webflow. And we can see this panel over here with almost all the things you can do to this grid component, all present here, really nicely designed, but really squished with icons, because everything you may want to do has to be here. And it's not even that you can have conditionals or parameters or formulas over here. It's everything, it's a value, and it's static in a sense. I call this the everything everywhere all at once UI, which is if it's a feature for the grid, it has to be here, or it has to be hidden in another section, but it has to be. So you don't know what's relevant to the configuration of this grid at the first glance. You don't know what here is important or what changed, because everything is there. You have to know the defaults and read and parse to know what is relevant. Languages and code don't work that way. In languages and code, you say what's relevant, and everything that is not said is irrelevant or implied from context. So I want to solve that problem. The other one is the add it to a menu problem. So in Office 2003, they started collecting metrics to see which of the 4,000 commands people were using, and 80% of the users only used 2 commands, copy and paste. And they realized that nobody used all the features, but everybody used a different set of features. That's the long tail of problem solving. And it didn't help for the core problem, which was discoverability. because users kept on requesting features that were already in the tool. So hiding it into a menu made it so that people couldn't find or didn't thought of looking for the solution in the tool already. They thought it was missing. Or if they wanted, they may not find it, even if they thought it should be there. Another problem is what you see is what you get, except for all the extra cron you need for manipulation that you get with the idea of YCWig, which works for some sub problems, or it may work for others when the solution is concrete and you can see it and you can manipulate it. But it may not work for abstract problems where there's not a representation that makes sense, or you have to come up with one and may not be the right one, or people will have to learn it because it's not there's no default representation. And then you have to put on top of all the cron for the direct manipulation, which stacks on top, and you're no longer manipulating the thing, you're seeing and manipulating the thing plus the cron for manipulation, which I don't think it's at the extreme level like here. I don't think it helps a lot. So over a couple of months ago, I created a file called bad GUI, and I started taking notes of all the things that I found annoying about the current way of graphical user interfaces, because in the groups I'm around and adjacent, we usually complain a lot about the current state of programming, but I don't see many people complaining about the current state of user interfaces. And maybe because I'm in the wrong places or I'm not invited to the right places, so I decided to kill the Buddha, basically. One of the main questions I had is, how do you build a UI for complex commands like ls, curl, OpenSSL, and ImageMagick? And a couple of months later, somebody actually did the work and created this mockup, which is a UI for OpenSSL. And I think this picture summarizes the problem. If you see this at a first glance, how you read it back, what this UI is telling you that it will do. But also the write is a problem. Writing, telling this UI to do something, how do you find things? You have to scan and read everything. You don't know what's changed or what's relevant and where things are. Things are hidden. Probably in this view, all these tabs may have 80% of all the available options hidden. And if you have to do some options here and another tab, you have to go back and forth. You cannot put them side by side. I think you get the idea of the problem. So UIs to configure complex things with the current ideas and abstractions, I think it doesn't work. That's why still we have CLI tools and programming languages and scripting languages. How do you read the tool? The UI was one of the main questions, and I started looking around, but also the reverse. Once you have the UI, how do you get the mental model of what this current state will evaluate into? What will it do? And I started looking around for eye tracking for UIs, and I couldn't find much. There's a lot on landing pages and websites for marketing purposes, but there's not a lot of how do we read and where our eyes go when we are trying to read a UI to know what's going on. The common pattern when reading textual things and UIs and pages is the F pattern, from top to bottom, from left to right. Mostly we read the top side and we scan top to bottom, left to right, and outside in, and you see that we scan less as our eyes go lower. So that tells you a pattern of how you should arrange things for readability. And I was thinking of how to apply this to graphical user interfaces, because the current way of doing UIs, how do you read this? Is it displayed and laid out in the order that you would read it, and when you're reading it out loud, it will make sense? I don't think so. And are all our toolkits and libraries for UIs made to create this kind of UIs? The other problem with UIs is place-oriented programming. What this shows is the current state of all the history of all manipulation, and we have to know a lot about the tool and the problem to parse what happened and what are the effects of this and what's different and what changed and how it will evaluate, because it's the current state of all the mutations, basically. I was thinking of different alternatives, like the cat on the keyboard problem. You go to get a coffee and your cat walks on your keyboard, and you come back and you have to see what changed so you can roll it back. What would you do? And the same if you come back from vacations or you are in a new project and you have to, you're using a UI tool, a no-code tool. How do you read it to know like what's going on, what's relevant, what's different, what's important, what's critical, what changed, what should not be changed, and why something changed? And I don't think UIs help in that. I think that the current way of doing UIs, we have a couple of syntactical elements, but no semantics, and it's not a language. It doesn't have rules of a language to create higher level meanings and abstractions. Going full iconoclast, like I think overlappable windows are mostly for small screens of the past, mostly. Like they may be useful in some points, but I don't think we should use them a lot. Pop-ups, the same. And navigation, and also like static navigation, in which the structure of the application is like set in stone and hard-coded, and you cannot move things around and put things by side or rearrange them or reorder them for different problems. It's the way it is. This makes for unmalleable and unmoldable systems. And also going back to why are we here? Where do we come from? And thinking that Xerox PARC was created to create the office of the future. And the office is all about like forms and paper and processes. So what you get out of that is a UI with abstractions for forms and processes and steps and things like that. And like seeing like a bureaucrat, you create these abstractions which create these systems that reflect the initial like intentions, and it may be the global maxima, but I don't think it is. So we should like look around and see other ways of doing UIs for end users. The previous project in Stadeck, I tried to do a full drag and drop first UI, and I thought that will make it easier. And I saw non-technical people use it, and it was really painful. What can I drag? When can I drop it? Even when I made many different features for that. Precision, the amount of times that somebody misses the drop target, even if it's not that small. Long drags are annoying, and long drags across different sections where the target is not currently visible. And doing a long drag and missing, the problem of dragging with touch devices and the finger on top of the thing you're dragging and the finger on top of the small target you're dropping into. And I can go on and on. UIs don't provide any natural hierarchy like text, where we have like an index and sections and paragraphs and subsections and bullet points and nested bullet points, where there's a natural hierarchy to the content. So we can scheme and read at a higher level the titles, the paragraphs, or the first things, or the top level bullet points. There are many ways to scan and to search on text that are not available in UIs. The current way of doing UIs is basically nesting boxes, Mamushka style, and at some point you paint yourself into a small box, and there's a new requirement where you want to put a node or an error message or something to close to the thing that you want to be related to, and since it's a small box, it will not fit, or it will break the layout, or it will look really ugly. So maybe nesting boxes is not the right way, unless we have infinite zoom, which has been tried, and I don't know why it's not working. So maybe nesting boxes inside boxes is not the right way, unless we work with zoom and stuff like that. A businessy problem, but it's a real problem. We at Instadeck, we call it the 15-minute problem. I've seen a pattern where people sign up to the software as a service version, and after 15 minutes they cancel the account. And even when we try really hard to add onboarding on top, it's not so well integrated into the product to guide the users, to let them by themselves learn to use the tool to solve the problem before they run out of willingness to learn about the tool. And features that constantly appear, like templates for common tasks and reuse of things that were already created or deriving from like a thing that the pattern I've seen is like this, but they say, I want something like this, but just this little change. And how do you achieve that? UIs are not good at composition. I think building UIs is more like stacking bricks than like building an arch, citing Alan Kay. And reuse is not something that happens by default. Like in programming, if you create a function, which is the standard way of doing things, then you can reuse that function. You may refactor it a little bit, but the default way you do things is the way that allows for composition. In UIs, it's an extra step and makes things more complicated. And I think a good summary is Greenspan's 10th rule of UIs, which is any sufficiently complicated UI contains an ad hoc, informally specified, book-reading, slow implementation of half of a configuration language. And configuration languages have the same rule, which is half of a programming language. So maybe we're doing things the wrong way, and I'm trying to see if there's an approach to solve it. So where's my mind while I was thinking of all of these problems? I was thinking a lot on recursive UIs, which is, or fractal UIs, which is a way of building UIs where you can zoom into any place of the UI, and that alone is an application that runs, and all the logic is can run if that was the root of the application, and can run if I take that subtree and I put it somewhere else. So it's basically building UIs in a way where there's no root, there's no center, there's no beginning. I mean, there's one for the current incantation, but any subtree on itself can stand alone and have and run all the logic that is relevant to that subtree. I mean, something may not work because something outside has some understanding of the inside and reacts, but that subtree alone can run, and everything should be developed as if there was no root. Readability, I already mentioned how people read UIs, how to take ideas from how we read into UIs. The idea that JSON and YAML are not the best fit for trying to extract logic out of programming languages into configuration because they lack something that XML had that I think it's a good idea, which is this idea of the head, the attributes, and the body, which the JSON and YAML don't have. Like the tag name and maybe the namespace tells you what the rest is, and then the attributes are scalar values that like parameterize the head, and then one or more body items in a linear sequence where the order may or may not be relevant. I think it maps better than JSON and YAML, but we don't have, like, XML has many problems, so I'm not saying the solution is to go back, but I think we miss some of these things like namespaces, head, attributes, and body. The reverse of what I complained, malleable modular systems, what's the minimal set of static CRUM that the system can have so that everything else is part of the moldable part and configurable, so your workspace is just more data and more configuration, just it's displayed in a presentation style, but you can switch to the tree configuration and change it by hand and even like parameterize it. You can like abstract a way to create environments based on configuring the system itself. There's something interesting about object-oriented, which I think makes it better than functional programming, is that the dot-driven development. You grab the object and you do dot, and it will tell you all the things that you can do on the object, and basically it restricts the context of what's possible to the object at hand. Functional programming can emulate it in different ways with arrows and stuff like that, but like the object dot gives the tools and environment enough context to restrict the search of what is possible at that point in the development. The functionalization, how to basically make everything data so that it can be serialized and shipped around and run in different places and different runtimes and different environments. The idea that, code is data and some code is convenient as data, not like the fact that code is data is, it's a fact, but some code can be conveniently presented and manipulated as data. And a kind of manifesto or summary is from left to right, from top to bottom. This from how we read, from outside in. Also, like people understand like PowerPoint slides and bullet points and outlines and Notion. That the outside is more general and is related to the inside in this case of parent-child, and the inner side is more specific and related to the parent. From concrete to abstract, you should, like in the REPL, you should start manipulating concrete values, like strings and numbers. And once you get what you want, you abstract it, but only then. And at every point, the thing can run, and every name or abstraction should have a default value so that if you don't provide the parameters, it has a default behavior. Always it should run, and like it always should be concrete. It's not that when you abstract it, now you have to provide values. The values should be there and could and should be probably the ones you had before you abstracted. And like a benefit of visual and graphical interfaces is that when we want to use a value or a thing in more than one place, we not necessarily have to introduce a name, because a thing can be in more than one place at the same time. So you don't have to name a thing that you want to use in more than one place. You just have a reference type, and it will be presented in every single place where it's referenced. You don't have to name it. And avoid scopes if possible. I've read and seen that like people, it's not a natural thing. Scoping is not a natural thing. I believe that the idea of frames from Minsky and the idea of context, like people understand frames and contexts and maybe use that to present scoping, but not like lexical scopes in programming, if possible. Some of the inspiration from code, I want to avoid the Turing tar pit. I'm inspired by code, and later I will say what I'm inspired by, but I want to avoid the Turing tar pit of code, which is in every single place, on almost every single place where you place the cursor in a program, everything is possible, but nothing of value is easy. And also the white canvas problem, which I've seen also with previous versions of our products, is that if the default state of something new that the user creates is a white canvas, and the user has to know what problem they are trying to solve and then to map it back to what has to be added, instead of starting from the solution and then filling the details. That's something that programmers do that I've seen like people block a lot. They like to work from examples from similar things and change it until they get what they want. They shouldn't start from a white canvas. What I want to get from code, it's a lot. I want the builder pattern, which I mentioned before, the driven development. Since the UI is represented as a kind of a tree, as an outline of a basic data structure, like the idea that it's better to have 100 operations of one data structure than to have 10 operations on 10 data structures. The core data structure of GlooEye are like the node, the reference, and that's almost all. So I can have linters and walkers that can go over the tree and find like sub-linters for each domain that will check and tell you if it makes sense, and if it makes sense to refactor, or if there's a better or simpler way to do it, like a Clippy. And pretty printers. Reordering of nodes is allowed, but sometimes the natural order is known, so why do I have to reorder it by myself? For example, if I make an HTTP request, I want to have the method, the URL, and then the header, then the body, and if I make in a table, I want to have the header, the body, and the footer. Like even if I have it in different ways, the the interpreter for that domain should like order them when it's parsing it, but also it can reorder it in the presentation if the user decides to pretty print it. Also diffing, it's a great way to see like what changed, what was the difference between the current version and the version I have running on that server. REPLs, run and see the results, and change and see the results. Refactoring, as I said, together with the linter, like there's an easier way or simpler way to do this. The idea of libraries, the application is not a whole that is delivered like a monolith, but there are different DSLs, I call, that you can load on demand if you need them, but if you don't need them, you don't have to load them, and you don't have to see them. Probably you can have like different like profiles where you're working on one thing and you will see different DSLs, and in other contexts you will see others. And how do the idea of protocols to achieve composition, nodes tell which protocols they implement, and also tell which protocols are required for their children's and attributes. So two DSLs don't have to know each other to be able to be composed. So if something knows how to generate HTML DOM, then it can be used in anything that expects the HTML DOM. And if some attribute expects a number, you can do arithmetics on it. And if something expects a string, you can do string manipulation on it because of the protocols. So the wiring is like combinatorial by protocols. It doesn't have to be done by hand. From configuration, I want to get the declarative side of things, and how it usually pretty like optimized for reading it and understanding what's going on. From UI, what I want to avoid, all the previous rant I mentioned. And so what are the constraints of the project? This should be my source of income, so I need to get it into a shape that can be used by other people, and the ultimate user validation is that they have to be willing to pay for it. So it has to be not only useful, but easy to use, and it has to solve a problem that people are willing to pay for it. And because of that, also I need to pick my battles. I will try, like, there's a core set of ideas that I think are new and I'm trying to apply to solve these problems, but others I will take ideas that exist. The UI will be trying to get many things from Notion style UIs, because people get them and know them, and there's a lot of design and work on that space, so I'm not going to reinvent things I don't need to. So in a next video I will do a demo of the tool, and thank you.